to do the comparison? Lakshmi? Priya?
Sir,
See, this is actually what data?
predicted.
So this is your ground truth, right? But I want to make the comparison between them. Okay, so this is somewhat like if I want to check for the what is actually the input data. Okay, in that case, so this is the visualization is not comfortable right here in this Jupyter notebook. Okay, so that's what when we shifting now we are shifting to the like the practical usage part. So far we were using Jupyter notebook for the learning purpose. Okay, now we are going for the practical implementation purposes. Okay, so like we want to develop a project. It's like a small project we are starting up with. Okay, let's go ahead and use the spider, learn the spider. Okay, it's very easier. Okay, so we'll learn the spider now. Okay, and we'll see how it is different from your Jupyter notebook right now. Okay, so go to your Anaconda navigator. All of you open the Anaconda navigator and launch the spider. So this will launch the spider. Spider is starting. Okay, all of you go to the view. All of you go to the views. Okay, window layouts, choose MATLAB layout because I prefer using the MATLAB layout, so all the information is clearly visible here. I'll explain how does it looks like. First point, when you open, go to the view option, select the Windows layouts and choose the MATLAB layout. You guys can play around with that later on, but as of now you can choose the layout which I have selected. So when
C uses
no, it is throwing me something. This is a working directory for
newly opened consoles,
hmm,
for the file explorer, for
hmm,
the find in the files plugin,
hmm,
and for new
hmm, new files created in the
files
editor.
created in the editor.
Okay. See here actually you can browse for the folder. Like in Jupyter we didn't had much option to browse for the folder. Only we could choose it in the desktop or in the documents. So only few options. Like you can create actually you can whatever the folders you like you can create it. Okay, here I can go to this browse for folder option, browse a working directory, because it's for meant for project development mainly. Okay, so I'll go to the media. Here I'll create a new folder. Okay, or you can go to the desktop and you can choose the already created folders also, you can choose it. It's up to you. So because here in this particular spider you have got all the options. Okay, so I'm creating a new folder. Okay, facet BIET. Okay, MLP. So this is a folder we have chosen. Facet BIT MLP folder. Okay, so once we have chosen this folder, once you have this folder in your hand, okay, So the next task we'll be doing is, okay, now create a new file. Okay, so you can always create a new file here and save that file name. So linear regression. No need to mention the file type, it automatically takes it. So you can see a linear regression.py, the file has been saved. It is in your current folder. Right. Here all the files will be names and function names will be shown in this pane. This is mainly for the outline. So this is console where you could see all the results. Here it is a text editor where you will be writing your code, okay, like in other languages, language tools. Okay, so here all the variables in your like all the variables used in your program will be visible here. So this shows the history of what are the codes you have done, executed. Okay, any case you want to like read about the help section, so this is the help pane is there. So all these options you will get it when you have a view called as MATLAB layout. If you change the layout to spider layout, okay, this is spider layout, file and just the output, and the variable explorer is here, file explorer, you will get it in separate, like all them clubbed in one window. Okay, so for that reason I am choosing this MATLAB layout, okay, which gives me the complete view in one section. Okay, I'll be getting complete view in one particular view itself. Yeah. So let's start writing the same code. Okay, so let's start writing the same code here. Let me take up this beginning code where I try to read the file. So where I started, yeah, so I need to take these libraries, okay, and I imported it. So then you can actually create the cells here also, okay, by writing hash %, if you write it, it will create the cells. Okay, without that also you can write the programming, but it's better if you're creating a cells here also. Okay, so I'm just created a cell here by writing hash and %. So here in this portion what I am doing is, I can mention importing the, it is not mandatory, like you create a section importing library. See, the section has been created. You could see that there is a top one line and here bottom one line is appearing. Okay, that comes when you write a one hash and %, with a space. So this is the way you can actually so now read the file and display the content. Okay, data dot head, next. Okay, before that, like you can either go and execute the particular cell. Okay, for cell execution you have a debug options, like many options are there. If you click on this, so it will execute an entire file completely. Okay, so I'll first do that, execute the entire file. So it is running the whole file. It's throwing the error like salary underscore data.csv does not exist. How can I do that? What is the solution for that? Because I created a new folder, right? Here that file is not visible. Okay, so better I'll just copy and paste that file, okay, to the current working folder. Otherwise I need to give the path. Okay, I'll use the path option a little later. Now as far as concerned, I'll just copy this file and put this in the bit folder. I could see it in my, yeah, the file is there. Now I'm going to execute only this cell because this is already executed. Okay, you could see here library import completed, that is completed actually. Okay, here is the cell. What you can do is you can the shortcut control enter, you can execute it here, only clicking anywhere in this particular cell. It has given me the results. You could also see that here in variable explorer that particular variable is appearing here. Now you can double click on that and you can see all the values 0 to 29. It's very good, right? Data frame. So I could see that data frame completely. Now what is the next step? Now choose the independent and dependent variables. Now I will be choosing the dependent and the independent variables. So what are the dependent and independent variables here? Sanjay, Sanjay Haskell, Raghavendra Nirligi.
Yes, sir.
What are the dependent and independent variables here?
Year experience and salary.
Okay, which one is independent variable here?
Year experience.
Years of experience is a independent
Independent.
variable and salary is your dependent variable. Okay,
Dependent variable.
yeah. So we'll split that now. So already we have written the code for that. So I'm not going for describing and all. Okay, so directly I'm using the straight method of splitting the data. If you want to check the data, okay, so I'll just show you how this is appearing here in one plot. I'm just doing. So before that, a plot of data. So I'm just executing only this cell. How do you execute only this cell? Can you see these options here? Run current cell, control enter is the shortcut. So just click on that. So even that is also giving the result. So all results will appear here in the console window. So this is the engine where you can actually feed your data. Even you can say example, I can write directly here data dot tail. I could get the last few samples. Okay. Instead what you are doing is we are writing it here the code and checking the results here. Okay, so that we can save all the codes whatever we are writing it. Okay, but you could also see the history. From history you can copy the codes whatever you executed. Okay, and run it. You want to clear the screen whatever is displayed here, you can do that by typing CLEAR, clear. That will clear the console window. Okay, in the spider notebook. Okay, just a hint, clear is for I'll write this at the beginning, so that would be better. Okay, so clear, one second, basic commands, two commands I'll give it. Okay, one is clears the console window, not the variables from the memory. Okay. For example, you want to clear all the variables stored in the memory, you can do the reset option. Clears all data from memory. So you can see that after doing clear, still I have the variable data, still it is present, right? If I type data here, I can get the result of data, that variable, okay. But if I do the reset, say example, I'm executing the reset command, okay, you see it is asking for, you want to see once deleted variables cannot be recovered, okay. You can say yes, it has cleared that variable. Now if you're typing data, it is unknown variable, okay, not a defined, okay. So that's how you can make use of this basic commands, okay. Unlike your Jupyter notebook, once you exit from the spider, your data will not be saved, okay. So example, so what I meant was, I have executed this, you cannot put it here, it is only to this, okay. Even this is also, you cannot do it here, okay. Anyways, I'm executing this, I'm just so the file is there, it will get automatically saved, okay. I'm just closing the spider and restarting the spider again. It will take certain time. Sorry. Yeah, now here you could see that, wait guys, so it is launching the spider, it seems. Yeah, now it is launching, wait a minute. Yeah, say once I restarted, so this is not visible, the data has been removed, okay, only the file is there, okay. Again so the folder which you created is not visible here. How do you do that? You can go here and choose your folder created, okay. So now you have this file, okay, so that is open. Now you can run and check it out. Only codes will be available, the data in the console window and the variable explorer will be removed, okay. Like in spider, the outputs will be saved, here not the case, okay. But if you want, you can save the image, the results, if you have it, you can save this image, okay. Now here any option you get will be different. Now let's move on to the what is the next step? Choosing the dependent and independent variable. So going back here to the code, and yeah, so this is the dependent and independent variable. After this, model evaluation purpose, split the data into training set and test set with a 25% for test and remaining 75 for training purpose. Okay, so this is the ratio 3:1, 3 per okay. Let us do this now. So for that you will be using this library called as SQL learn. We have done that, train and split. So let us execute this cell, and I'm again executing this cell. Good, see that dpn test, which is splitted values, dpn train. You could see that this is shuffled data. Okay, you don't want to see this shuffling, and indexes also you want it in a sequential order. You want the indexes to be in a sequential order. Okay, so what we can do is we can mention here, we can one second, you can mention random underscore state equal to 0 and redo this. Say now if you're checking this 25, 12, 21, and if I do, I'm repeating this operation once again. You could see that. So this is changing, like each time the shuffling will be little different. Okay, so now it is being controlled to it is fixed. Okay, if you are mentioning a random state as 0, otherwise it will be different at different instances. Okay, see, if the values are changing, you may find some difference in the outcome what you are getting it. Okay, so let us do the build the linear regression model. Build the linear regression model using scikit. So already we built yesterday, so let's take that library. The model has been built, so let us check with the verify with the test data. Okay, so for predicting, so I can pass lr dot predict of. Okay, I can say here these are the salary data, right? So and this is the output. Okay, this is a dependent variable, that is the output, and corresponding input. If I feed this value 1.5, okay, 1.5, what is the expected? No, this is not giving us any output. So because it should be in the different format, let us try ind underscore test of 0. ind test of 0 is 1.5. okay, for this one second, 0:1. Yeah. For first sample, okay, that is for 1.5 years of experience, corresponding original value is 37,731, right? For this, the corresponding value is 37,731. What is the output I got is 41,056. Okay, so like slightly closest value what I received. Okay, so I can pass the whole test data and I can check the result. Okay, so this is the result predicted. Okay, I'll save it in a predicted result. Okay, PR is equal to, okay, you'll see, so clear. So now why I'm not able to get this? This is PR, this is the original expected outcome, okay, and here is the corresponding test date. Okay, now Naveshri,
Yes, sir.
can you do this comparison now easily? The unknown data set, corresponding ground truth, and here is the
Yes, sir.
result we received, right? So in a better way,
Yes, sir.
you can control the how you want to run the code here in the Spider environment, and how to visualize the data is also much more clearer in that. Comparisons we can do it very easily here, right? 1.5 years experience, this is expected and this is what we received. Okay, 10 years experience, this is what expected and what is we received here. So altogether, this is the conclusion we are making out of this. Okay, so this way it is better using Spider for the project development phases. Okay, so let us try now plotting the input, plotting the trained data points, trained data, and test data. Okay, so I'll do a plot. Okay, plt dot scatter plot of your dependent. Okay, dpn. So that is, first will be x-axis will be your experiences, and based upon that salary, independent, training data underscore train, comma, your corresponding dpn underscore train data. Here I am plotting this with a color that is equal to navy. So all these points will be plotted in a blue color, or I can say, you can simply write it as a black color. plt dot show one minute. Independent train data, comma, dependent train data. Okay, let me mention, try this. Okay, here I need to mention the color separately. Color is equal to black. So if you want to choose the color, you can choose it. Okay, I had chosen these points. Okay, these are the my original data points. Okay, now they will be fitted onto where they will be fitted onto this trained data, right? So let us plot that straight line. How does it looks like? Okay, onto this data point only. plt dot plot, again independent training, that will be my x-axis, comma, I'll be plotting the LR dot prediction on the training set of data. What is the training set? That is here. Here is that. You could like to give a, yeah, you can see that this is the line which is fitted. Okay, see all these data points now will be pointing to this straight line. Okay, so that means the person with the experience 10. Okay, if you look at this, okay, there is some data point which is here. Now it has been moved to this position, right? Yes, one second guys. Rachna,
Sir,
so what is the meaning of this? What it is actually telling us?
as the experience increases, salary also increase.
No, this is the straight line. What is the straight line? This is your predicted line. There is the straight line to which these data points are fitting. Okay, so that means, say example, this is a data point right now. This is corresponds to certain like yeah, let me,
Yes, sir.
one second, I'll just show this in a one second. For the paint, let me do this. Okay, can you see this now? Now consider this is the data point. Okay, this is x-axis is what? Experience. Y-axis is what? The salary. So this is a straight line. Now Rachna,
Yes, sir.
so now this is the actually point is this. Okay, now it has been moved to this position.
Yes,
Okay,
sir.
that means if you check the, if you pass on this corresponding input, okay, so instead of giving the salary, okay, so maybe it is a 9 years experience candidate. Okay, actual salary is this one. Now it has been if you look at this is the salary it will give. Okay, so this is the ground truth, this is the ground truth, and this is a predicted value here. This point is the predicted value here. Okay, so this is
Yes, sir.
the, this point is called as prediction. Okay.
Predicted.
Yeah, and similarly, what about this one at this position? Okay, this is actually the predicted, this is your ground truth. Okay, so that means all these data points now will fit onto this straight line. Okay, so this difference between the ground truth and the prediction is called as what? Residual error.
ASB.
Residual error. Okay, we try to minimize that error. If you're looking at here, the data points are very close to this line. Okay, in regression, that's what we do. We try to fit this straight line to the this data point so as to minimize this residual error. Okay, now we'll check the similar thing what will happen in my test data as well. Okay, so let us do the same plot on the test data as well. Now we are doing it on a test data. This is original trained data. Okay, so let me take this. So now if you're taking test data, will it fit on the same straight line or a different straight line? If you're taking your data points, test data points, will it fit on the same straight line or a different straight line? Rachna,
Sir?
if I'm taking in new samples, okay,
Yes, sir.
so whether the new samples will be fitted on the same straight line or a different one? It will be on the same line, right? This is only one time we fit the data. Once we fit the data,
Yes, sir.
we assume the rest of the data which you want to test it, okay, so will be fitted onto the same data point only. It is,
Same.
yeah, it is like whatever the slope, okay, whatever the intercept you calculated, so using that only, then the rest of the data points will also be calculated. Okay, so that means here I'm changing this as your test data. 1 minute. And this is your the dependent test. Okay, but what about this one? So this remains the same. There is no change on this straight line. Okay, this is the same straight line to which I am checking how this original data test samples will be fitted. Okay, so let us do that plot. I could see this new result. I have in my test sample, these are the samples. Okay, so 1.2 and 3 are and 4 points are exactly on the straight line, and remaining 4 points are there which are close to the data points, which are very close. There are no outliers. There is no data point which is very far away from this straight line. Okay, most of the data points are close to the particular line, the straight line which we have predicted. Okay, so this is your basically the regression analysis. Now if I say now I can take this model, so that is lr.predict method. I can use it to predict salary for any person with the experience, any kind of experience. If you say there is a person who is having a experience 6.6 years, okay, so just pass on that and your model is ready to give the salary expected. Okay, what salary you can give to that particular person. Clear? So please guys, all of you completed this? If not, please complete this one. So well, I'll show you later on like how to compute the MSC, how do we can minimize that MSC and all. Okay, what are the possible ways so that we can improve the performance of the model. Okay, this is for plotting. Okay, so we have plotted the data. So please complete it. Let's complete it. So this is a list of startup companies. About 50 companies list is there. Okay, names are not provided. Okay, so what is their annual profit? Okay, so which city they are located? Okay, how much they spent on R&D, administration and marketing. Okay, so based upon this, okay, our goal is to predict the profit. Okay, somebody want to start a new startup or somebody want to invest in the company. Okay, they want to see that how much they're investing here so that the investor get a profit, or a new company who want to start it. Okay, they can decide their sum. So example, they have some amount, okay, to start a new startup company. They can decide like how much portion of the amount they should spend it, okay, for a particular budget allocation. They can do it, okay. Which city, if they started, it would be better, okay. All this information they can easily make it out, okay. They can also get to know about what is the profit they can expect it by building a such model, okay. For that purpose, we have this 50 startup companies data set, okay. Using that, we need to build a model, okay, where that if the predicted profit is close to the these profits values, okay, then we can actually say that, okay, the this kind of investment, if you do it, if you budget allocate it on R&D this much, administration on this much, or marketing spend this much, we can expect a better profit in your company, right? So that we can do it. For that purpose, so I had chosen this data set with a 4 columns. What happens in the multiple linear regression? What is the difference between MLR and the SLR? In simple linear regression, Neetu? In simple linear regression, so how many dependent variables and independent variables we can expect? Neetu, DG.
One dependent and one independent variable in the simple linear regression.
Okay. And in multiple?
We have more than one independent variable
Yeah.
in multiple linear regression.
Expected outcome is always only one dependent variable, okay. Expected outcome is more, so dependency will be on the independent variables. There can be any number of independent variables, so more than one independent variables you have it, you call it as a you call that as a multilinear regression, multiple linear regression, okay. So how this formula now, y is equal to b naught plus b1 into x1 plus b2 into x2, so on up to b3 into x3, right? This is the formula. So this is b naught x1 is like y is equal to mx plus c. This much is y is equal to mx plus v. This portion. Sorry, 1 minute. If I remove this, okay. So this is your y is equal to mx plus c, right? Shashank.
Yes, sir.
So this is y is equal to mx plus c formula, right?
Yes, sir.
Yeah. So now I can paste this. This is extending to the y is equal to bn into xn. That is n numbers. Okay. Multiple linear regression. You can have more than one independent variables. Right. So b naught into your x0 here. X0 is always 1. Okay. 1 into the this corresponding variable. So now, so with this knowledge, what I'm doing is I'm taking an input data. As I already shown, this is the data set. Okay. So so please listen here what I'm doing it. Don't try it now. I'll give the time for you people to try it. Okay. Now you have this data set, and then I'm reading that, and I'm reading the first column to the last column. That means I'm considering these independent variables like this. So you cannot actually display when you have both the categorical and non-categorical data. Your data frame will not be visible clearly. You can see here the first 4 columns are splitted: 1 column, 2 column, 3 and 4 columns. So what are these 4 columns are? Shashank?
Yes, sir.
What are these 4 columns are?
This is speed.
No, these 4 columns, what are these 4 columns representing now? independent variables.
Independent.
Yeah, this one is acting as a x1, x2, x3 and x4. This is your y, right? So this is your
Dependent.
y dependent variable. So these 4 columns are your independent variables. So now I have separated that independent variables and the dependent variable y. So this is y. Okay, fine. So we have splitted that dependent and independent one. The next task is what? So next task is, like we have discussed in the class, that so how to handle the categorical data. Did we discuss or not? Preetham? Preetham?
Sir.
Did we discuss about handling the categorical data?
No, sir.
Hmm? Like when
No,
you
sir.
when you have a categorical data, okay, if you remember in the Excel sheet I discussed to you people, like when you have a pass, fail, like this text data, how do we convert them to numerical data? Remember?
Yes, sir.
Remember? Yeah. Able to
Yes, sir.
recall? Yeah. Fine. Good. So now here, is there any categorical data present in this data set? Yes, right? So there is a city names are
Yes,
there:
sir.
New York, California, Florida. Okay. So these are the city names. How do we do the conversion of them? See, I can do the label encoding onto that. Okay. So which column it is? State column. Right. So here if you check it out, this is the column name is state column. So I'm applying the label encoding onto that. Okay. So once I apply the label encoding, okay, onto that, so what will happen is, if you look at the data now, it has been modified to 201213. So that means, so the earlier this particular name was New York, so that has been modified to 2. Then you have California, that is 0. So then you have Florida, that is 102. So this is, what is the problem with this label encoding? Now these are just a plain city names, right? These are just a city names. Okay, in that case what I can do, I can convert it to a one hot encoding. I can convert them to a one hot encoded values. Okay, so just for your reference, okay, so I'm going to repeat it. So how the one label encoding, one hot encoding is done. Okay, here is the data set, right? I'm just taking this. Now to this label encoding, what is this label encoding, Preetham?
Sir.
So what is the label?
Giving
Value 2,
giving values.
0 and 1. New York again, 2, 1, 2, 0, 1, 2, 0. Corresponding one hot encoding. How we'll do it? One hot encoding.
So 3 columns.
Yeah, California, Florida, and New York. Okay. So California present, no present.
001.
001. I hope you guys remember this, right?
1,
Everyone
0, 0.
everyone able to recall this? Anybody want the explanation, still want to continue this? 1 0 0. At the end of this conversion, can I discard one column?
Yes, sir.
Yeah, we can discard because it represents the remaining coded values, represents the same value. Okay, so this is what we are doing it here in the one hot encoder. Okay, the function is called as, so this is actually not required, you need not to do this one, you need not to do this one. Okay, so this is only if you are having a one hot encoding label encoding is required, then you can go do the label encoding. Otherwise, if you want to do the one hot encoding, just go for the column transfer method. Column transformer. Okay, first you need to import the label encoder and one hot encoder, create a method called as one hot encoder, then use the column transfer. Use the column transfer. What is the method? Encoder. Which one? One hot encoder. Okay, so how many columns? Like 3 categories are there. Reminder is pass through. Reminder is pass through means it will do the it will apply the one hot encoding. Okay, so let me go to this one hot encoder and show the, like, you know, the details of it. I'll show you the details of this one hot encoder in the particular scikit library documentation. If you open the documentation, they are telling what are this. Okay, reminder is drop and pass through. So by default only a specified column is transformers are transformed and combined in the output, and the non-specified columns are dropped. Non-specified columns are dropped. By specifying the reminder as pass through, reminder as pass through, all the remaining columns that were not specified in the transformers will be automatically passed through. That means I am mentioning here to apply the one hot encoding onto the third column, column number 3, 0 1 2 3, right? So your state column is in the third column. Okay, so I am mentioning that one. Remaining columns will be kept as it is, they will not be disturbed. The remaining columns are not disturbed in this case. Okay, so what is the meaning here? One second, please. Three indicates column number 3, that is in bracket state, which has to be one hot encoded. Okay, then pass through indicates only the column mentioned is one hot encoded and remaining columns are kept as it is. Okay, so pass through indicates only column mentioned is one hot encoded and remaining columns are kept as it is. Okay, so now try, we'll do this now, applying. Okay, one hot encoding onto the data. So now I am doing this one hot encoding onto the whole data set. Okay, so whole data set. So let us see what is the result of this one. Actually, you got one second. Okay, here instead of doing it on the whole data set, let me do it on the x variable, because x is actually having your data set. Okay, so let me read it first. Okay, I'm applying the one hot encoding onto the x here. So this is not visible. Okay, let us display this x here. You could see that there are 3 more columns which we can see. Okay, what are these 3 columns? Pritam? Pritam? Lakshmi Putra Reddy?
So,
What are the 3 columns you are indicating now?
so like one not encoded.
These are one not encoded. The state column, now it was actually 1 column, now we have got 3 extra columns, right? So total 2 extra columns.
Yes.
So in this one column we have to discard it, any one column, right? So remaining
Yes.
3 columns are as it is. Okay, this is a one column which we need to discard it. Okay, because one column is acting as a dummy column. Okay, so let's remove that one now. How do we remove this? X is equal to x of all the rows comma 1 colon. So that means I'm dropping the first one. Just I want to execute this line. How can you do this? Is select this line and run this one. Okay, run selection or a current line. Okay, I executed that line. Okay, and now if you display this x, the first column has been removed in this, right? So now we have removed the unwanted column. Now we have this data. Now we can train our model. Okay, actually this is what you will be doing it. So label encoding is not required in this example case. Okay, because so label encoding is not at all required in this case. The reason is, okay, so we are directly doing the one hot encoding without applying the label encoding, not required. Just for your understanding, so you can check, run it and try it. Okay, just for your understanding purpose. Okay, so this is not required actually. In this particular example, label encoding is not required. So you know, earlier version what happens is, okay, earlier libraries, okay, so if you want to perform the one hot encoding, you need to first do the label encoding and then you should do the one hot encoding. Okay, but now you can apply the one hot encoding directly using the column transfer method. Okay, so earlier this was not there, now only you can use the column transfer method. Okay, this is what discarding the dummy value, dummy column. Okay, so that much we have done so far. Okay, yes. Wait a minute, guys. So noting the data type, both the data type to float. Okay. So let us do this. So now if you try to check x and this is your y, okay, so this is your x, okay, floating point values. Okay, so now we can go for splitting the data. Okay, so split your data, so that is x comma y, test size I taken as 20% for testing, and 80% of the data is for the training purpose. Y-train, Y-test is your dependent variables. I-train and I-test are independent variable. I-train and I-test are the independent variables. Okay. So the rest of the things, whether you're using a multiple linear regression or simple linear regression, only thing is you need to choose the number of independent variables. That's it. The method remains the same here. Once you split the data, okay, you have I-test, okay, so you have I-train, okay, so Y-test and corresponding Y-train data. Okay, so now here in this case, I-test, I-train are your corresponding independent variables. Okay, so now we are going to feed that data to your linear regression method. So I created linear regression method and applying the fit method, lr.fit I-train comma I-train comma Y-train. Okay, so Y-train is your dependent variable, so let me take it as a D-train instead, so that we can, yeah, so it is better, yeah, so D-train and D-test. Okay, so independent training data versus dependent training. So just we are computing that. Okay, so then we'll do the prediction, okay, by passing the test data, predict the test data. So now we have a test data result, okay, about the profits, okay, and corresponding, okay, so dependent test data, do the comparison. Okay, the closest values are present: 10328, 144, 146, 7771, 1917, 10, 116. So there is huge difference between this point and there is some difference between these 2 points. So remaining points are a little bit closer. Okay, so 166, 167 very close to each other, 110, 113. So that is the prediction we are done. Okay, so this is by using your multiple linear regression. Okay, so now so my next goal is to check out of all these variables which are playing a role in predicting the result. Okay, these are the variables, right? That is R&D spend, marketing spend, and the administrative spend, and then the cities they are present. Okay, so these are the 4 different variables which are playing the role in predicting the outcome, that is profit. Okay, so we need to see how many of these variables are significant, in predicting that result, how many of them are having a significance in predicting the results. So that is the thing we are going to do it in the next class, in the tomorrow's class. Okay, so now you guys do this. Okay.